What happens at mountains where we see volcanic activity? Day 2 of this lesson, we're going to talk about constructive and destructive property. So looking at this image, are volcanoes a constructive or destructive property? Answer that question in your GeoJournal. Keeping in mind that constructive means it builds things, makes things better, newer. Destructive property means it damages, break things down. In addition, I'd like you to answer this question. Do they make mountains bigger or smaller? So make a prediction on that. You're then going to be asked to watch this video. So watch this video from beginning to end. And then you're going to read this reading, and you're going to place this reading in your GeoJournal. Here is the reading. You can click on this link if you're absent, or you can use a piece of printed out and then add this to your GeoJournal. Okay, looking at these two pictures, what happens at mountains where we see volcanic activity? Is it constructive or deconstructive? So looking at the top picture on the right, this is on a piece of land or a continent, and this is a mountain at a continent or piece of land. Where the bottom one is still a volcano, but now it is an island. So do you think this is constructive or destructive? So in 1980, Mount Helens could be argued as a destructive piece of property. Most of the ash fell between 3 to 12 miles from its vent, but some was carried up to 150 miles to South Bend or to the south to Bend, Oregon, or 285 miles east to Spokane, Washington. So if you look at the picture at the top, if you notice, the very top of Mount St. Helens blew up, like the mountain is no longer there. If you look on the bottom left-hand picture, this is what happened with its pyroclastic flow. It demolished and destroyed trees and the land all around it. But look in the bottom right picture. It is of 40 years plus later. And if you notice, it's a beautiful, lush, beautiful green land. So the argument is it constructive or deconstructive? Now I want you to look at this slideshow. So you can click here. I'm going to share this tab. And what I would like you to notice is I would like you to look at this amazing site. This is an amazing site in the South Pacific. A yacht was traveling in the South Pacific when the crew came across a weird sight. Look at these photos and try and imagine the thrill of experiencing this phenomenon. A beach? Nope, it's not a beach. It's volcanic stones floating on the water. Where is the volcano? Unbelievable sight. So I had to take pictures because no one would believe it. This is a seismograph. NASA scientists were not here on accident. They were monitoring the area. From the wake of my yacht, we stayed on the edge of the water. Then this was spotted, ash and steam rising from the ocean. And while we were here, we were watching, look off in the distance. A plume of black ash, a huge cloud covering everything in red, even this far away. Then the sky turns black with ash and the ocean turns to gold from the sun's reflection. Out of the ocean, mountain peaks arise, more eruptions, ash and clouds. Then the mountain peaks rise higher within minutes, and a brand new island is formed. The creation of mountains. Ooh, creation of mountains. Can you imagine the thrill of being the first and only people to witness a new island being created where there was nothing there before? Okay, so now, ladies and gentlemen, what we're going to do is reflect on Yellowstone. If you've not been to Yellowstone, some of you guys have heard, Yellowstone is technically a volcano, but a volcano doesn't necessarily have to be tall mountains. In this instance, these are open sulfuric pits. And what happens is it's a thinning of a crust similar to a hotspot but it's more on a continent or large land. So examples around the world of different volcanoes. The cinder cone volcano is on Pompeii that we discussed in the previous lesson. A shield volcano is lava only, much like Hawaii, which we discussed in the previous lesson. And a composite volcano is a combination of lava and ash, which would be Mount St. Helens. So now let's look at the oceanic crust with continental crust. Do you think that will be constructive or destructive properties? Remember, oceanic crust means it comes crust from underneath the ocean floor. Continental crust means it's on land. So what happens in this instance? The plates come together, but how will the plates move? Make a prediction and draw it in your GeoJournal. And you're going to share your ideas with your class. So putting these ideas together, can an eruption of a volcano increase the size of the surrounding mountains? Why or why not? Make your argument. Why do volcanoes cause the changes in location and elevation that occur at the remaining 3 mountain sites? So most of our active volcanoes are located along an area called the Ring of Fire. And this is indicated in the picture. And so not only are they our volcanoes, but they're very, very, very active and strong. Note, the Pacific Plate is also the plate that seems to be moving the most around the world. So let's watch this simulation. This is oceanic crust meeting continental crust. And as you notice, they come together. And as they come together, there's some earthquakes. But if you look to the right, you see a volcanic arc. I'm going to play this again. And if you notice, when it comes together, we get volcanoes and a volcanic arc. And if you notice, there's a rippling or a creation of brand new land. So it's creating land, and they're getting slightly taller. So does this explain why mountains grow along the Ring of Fire? So this is something called a subduction zone. And a subduction zone is the place where the 2 lithospheric plates come together. So the lithosphere is the land underneath the ocean. One is riding over the other one. Most volcanoes on land occur parallel and inland to the boundary between the 2 plates. So like the picture we just saw, we get these volcanoes right next to a plate. And that's the end of the lesson today.